So for this project, you're going to construct confidence intervals for proportion and for the mean. And again, rather than using formulas to do them, I really want to emphasize using the technology to get the answer and then be able to talk about what it tells you. So rather than spending a lot of time working through the formulas, which the first example in the book, if we look at any of the examples in the book, you always see that that first example really goes through using the formula. So say we go to 8.2 and it walks through the steps here for how to conduct this test. And it gives some formulas there. In the first example, it says, how to construct this interval using the formula. As I've said in class multiple times, I don't want to emphasize taking the time to go through the formula. It can enlighten a little bit, and we do talk about it some in class. But when you're working through these, rather than using this messy formula that you see here to do the calculation, I would really prefer that you work through using the technology to do this. StatCrunch, again, makes this easier. Your take-home test that you'll have next week will make this, it'll be easier to use technology than to try to use your calculator on these. And because of the time involved on these, and I realize these take some time, because of the time involved on these, I do prefer to have you work on these on your own or in groups outside of class as opposed to giving a time test in class. So that's sort of my reasoning there. I like to communicate that and emphasize it. So I'll put it here again so you hear it hopefully as you're working on this project. And so in terms of using StatCrunch to get the confidence interval for any of these, again, here we have this big data set, right? And if I want to look at a confidence interval for proportion, then again, we're going to go stat and proportion stats. And we're doing it on one sample, and it's with the data. And I could construct a confidence interval for anything, again, that's categorical data where I call something success and something failure. We can talk about success in terms of quantitative data there, but I'm not going to do that. So let's say I wanted to look and say, okay, what is my confidence interval for the proportion that had, I don't remember what all of our different hair colors were. I will say brown hair. So suspect hair color being brown. And we just want a confidence interval for P. I'm going to use the 0.95 and leave this as the standard walled method for doing that. And when I hit compute, then it didn't give me anything because apparently there were no suspects with brown hair color. So maybe it was black, or maybe they had something else there. Actually, I think it was BR for brown. And when I do compute, then it says there was only one BR out of all of those, so I'm not going to do that. Let's change it to BL. And forgive my muddling around here. Didn't like that one either. So let's go over here and look at suspect hair color and see what it is we're dealing with that I have to have in this case here. So there we go. It was BRO for brown, BLK for black. So that was why that didn't work. And if I do go back in there and let's change this to BLA for black, and I do this compute here. Oh, that's hair color. So what do we want for hair color? BLK. How's that? And then hit compute. There we go. So this would tell us that out of 150 people stopped, 109 had black hair. And so the sample proportion of success we have here is 0.727. That says that about 73% of my sample had black hair. And over here, the confidence interval is from 65.5% or 0.655 up to 79.79% or 70, well, I guess 80%. So between 65 and 80% of our sample, of our population would have black hair. And again, this is the sample, And the population, in this case that we're taking it out of, is all the different stops. And so we can get that it's between 65 and 80% of the population of all stops had black hair. And so we can do that for any proportion, just depending on what we want to call success and what we want to call failure. Um, so we looked at the proportion of females, we looked at the proportion of people by race, and so you can easily set that up in each case there. In terms of looking at a one sample mean, so let's say we want to look at people's mean, and again, I'm going to look at age here. You're going to look at weights and heights, but again, I do t-stats because we don't have the population standard deviation. So I do one sample with data, and let's say I look at suspect reported age, and we can do this individually. We can break it apart by sex if we wanted to, or by race or other things. But if I look at a confidence interval for mu, the population mean of all people stopped, based on what we see in our sample, and we hit compute, then what we see here was that our sample mean was 28.10 years old, and that the confidence interval we'd have would be from 26.1 up to 30.1 years of age. So again, breaking it apart, if you wanted to group it, then we have, you could group it by suspect sex and see whether there was a difference in age. Looks like the males that were stopped were older than the females, but the confidence interval was wider for the confidence interval was wider for the females because there were so few of them in this sample that we were looking at there. So hopefully that helps. Again, the interpretation here would say what we're 95% confident that the mean age of all males stopped is between 26.2 and 30.4 years old. And we could check that in this case because we do have a population of all data, but you're working with a sample there.